Hey guys, today we're taking a look at section 4.2, reflections. Our learning targets for today is that we can reflect a figure and perform a composite of reflections, and then also being able to identify lines of symmetry in geometric figures. The other day we said a reflection is commonly known as a flip. It is a transformation that uses a line, like a mirror, to reflect a figure over. This is called the reflection line, or the line of reflection. So notice over here on the right hand side, we've got point P. It's being reflected over line M to form the image point P prime. So here is our pre-image P, and it's being reflected over that line M. And you'll notice that the segment that connects P, the pre-image, to the image P prime is being bisected by that reflection line. The reflection line is the perpendicular bisector of that segment from P to P prime, from the pre-image to the image point. All right, let's look at an example here and see if we can graph the reflection of triangle ABC, where A is 1, 3, 5, 2. Here's A, here's 5 over and 2 up. Here is B, and C is 2 over and 1 up. So here's A, B, and C. And we're just going to connect those guys, make a nice little triangle here in the coordinate plane. Take a second to do that on your notes. All right, we want to reflect this over the horizontal line, y equals -1. So let's draw in that line, y equals -1. It's a horizontal line here. And this is our reflection line, y equals -1. So if I want to get the proper image points here, I am going to draw a line so that this line, y equals -1, is the perpendicular bisector of that segment. So if I start with C, I'm going to count down to that line, down 1, 2, and I have to keep going on the other side, 1, 2. So here is C prime. B prime then could be found at 1, 2, 3 down to that line. So 1, 2, 3 on the other side of that line. Here's B prime. And then A prime, we're going to count down 1, 2, 3, 4. 1, 2, 3, 4. Here is A prime. All right, now if we connect this, these 3 points here, you should see triangle A prime, B prime, C prime look like that reflection image over that line, y equals -1. Next, we're going to reflect that same pre-image, triangle ABC, over the vertical line, x equals -2. So let's start by drawing in that vertical line. Here it is, x equals -2. And we're going to do the same thing. We're going to start with each one of these coordinates, and we're just going to reflect it across that line. So we're going to count from A to the line, 1, 2, 3, and 1, 2, 3 to the other side of that. Here is A, and we're going to just call this one, actually we won't call it double prime. We'll just call it A prime. C, we're going to do the same thing, 1, 2, 3, 4. 1, 2, 3, 4. Here is C prime. And then B prime is going to go from 5 here all the way to -2. That's 7. So now we got to go from -2, 7 more. That's going to put us out here at -9. Let's just say this is B prime. And again, if we were to graph this triangle, you would see that reflection over that vertical line, x equals -2. Okay, those are some horizontal and vertical line reflections. Here are some, 4 very common and basic reflections that we do in the coordinate plane. We reflect over the x-axis, and when we do that, our ordered pairs, which we will describe as AB, go to the ordered pairs A, -B. In other words, when you reflect over the x-axis, you change the value of y coordinate. All right, he changed the value of the y coordinate. So AB went to a -B. When we reflect over the y-axis, we are going to go AB will now be -AB. In other words, we are going to change the value of the x coordinate. All right, how about if we reflect over this diagonal line y equals x? Well, when we reflect over the line y equals x, all of our coordinates a, b will be switched around. The x will become the y and the y will become the x. So we'll just call this switching the x and y's. All right, and finally, here's our fourth rule. When we reflect over the line y equals negative x, which goes on the other diagonal through the origin, we take all of our order pairs a, b, and they now go to negative b, negative a. So not only do they switch, but they also change values. So we're going to switch the x and y's and change their values. All right, let's do a few examples here. We got a rectangle STUV. It's got vertices at 3, 4, 3, 1, negative 2, 1, and negative 2, 4. Take a second to draw that figure out. So here's 3, 4. Here is 3, 1. Here is negative 2, 1. And here is negative 2, 4. So this is your S, T, U, and V. If we graph those lines and connect those dots in there, we've got ourselves a nice little rectangle. All right, there it is. There's our pre-image. We're going to do a reflection in the x-axis. So remember, when we reflect in the x-axis, we're going to change the value of the y-coordinates. So I'm going to write the coordinates for S prime, T prime, U prime, V prime right down here, and then we'll take a second to graph them. Our x-axis, remember, is that horizontal axis. Y-axis is our vertical axis. So when we reflect in x, we're going to change the value on the y-coordinate. So S is going to go to 3, negative 4. T is going to go to 3, negative 1. U prime is going to go to negative 2, negative 1. And V prime is going to be negative 2, negative 4. All right, take a second to plot that figure. You should see that that lies right down here in quadrants 3 and 4. Next, we are going to reflect that same pre-image figure, STUV, in the line y equals negative x. So when we reflect in the line y equals negative x, remember, we switch the x and the y, and we change their values. So switch the x and the y and change values. So let's do the same thing here. Let's write the coordinate out for S prime, T prime, U prime, and V prime. All right, for S prime, we're going to switch the x and the y and change their values. So that becomes negative 4, negative 3. T prime, they're going to switch their order and their values. That's negative 1, negative 3. U prime, I'm going to write it out here, it's going to switch the order and switch the values. So this is going to become negative 1, positive 2. Now remember, if it was negative to start off, it's got to change value to go to positive. And then V prime is going to switch, it's going to become negative 4, positive 2. All right, once again, take a second to graph those points in the coordinate plane and see what that reflection looks like in the line y equals negative x. All right, moving on to example 3. We've got triangle RST. It's got the coordinates negative 1, 5, 2, 7, and 4, 4. We want to use the rules for reflection to find the image coordinate after reflection in the line y equals x, and then also in the y-axis. All right, so let's reflect in the line y equals x. Remember, our rule here was that all of our coordinates a, b, switch. They go to b, a. So our pre-image coordinates here are negative 1, 5 are going to switch and go to 5, negative 1. 2, 7 is going to go to 7, 2. And 4, 4 is going to stay there at 4, 4. Next up, we're going to find the coordinates of our image triangle here after reflection in the y-axis. And remember our rule for that one. When you reflect in y, it changes the sign on the x coordinate. So it goes to negative a comma b. All right, so our prime now is going to be positive 1, 5. And then we're going to change the value on the x here for s. That's going to be negative 2, 7. And then we're going to change the value on this x in negative 4, 4. Well, take a minute, pause the video, and graph all three of those triangles. The pre-image triangle, the image after a reflection in the line y equals x, and the image after a reflection in the line the y-axis. All right, for our final example here today, we're going to scoot down and talk about lines of symmetry. When a figure can be copied onto itself over a line, known as the reflection line or the line of symmetry, then we say that that figure is symmetric. So tell if the following figures are symmetric. If so, draw a line of symmetry. All right, so looking at this first one here, we got the outline of that airplane. If we zoom in on that just a little bit, we can see that if we draw a line straight through the nose of that plane, right back out the tail, this is a good line of reflection. This left half of the plane can reflect over that reflection line, the line of symmetry, to mirror what's on the right side. All right, our next example is this big apple here, and we might think this looks symmetric, but if I were to draw a line through this, I'll notice that this leaf over here and the stem don't match up. They're not mirror images of each other. So for my apple here, I have to say that it is not symmetric. All right, how about our three arrows here? Looks like if I could draw this horizontal reflection line in there, that would be a good reflection line. Okay, so anything up here on the top can be reflected over that reflection line. So this has one line of symmetry. All right, finally here, our little atom molecule symbol looks like it's going to have many lines of symmetry. I can draw one straight up and down. I can also draw a line of symmetry at an angle such as this, and likewise through there. Are there any other lines of symmetry? How about right through there? That looks like a line of symmetry as well, straight through the middle, left to right. And it looks like I got one more line of symmetry that I can draw in there. So this one is very symmetric, and I can see that I got 1, 2, 3, 4, 5, 6 lines of symmetry. So here I'd say, yep, this is reflection symmetric. There are 6 lines of symmetry.